To shade a system of inequalities works the same way as shading single inequalities. You just put more than one inequality on the same graph. In this system, I have x plus y is less than 4 as my first equation, and y less than or equal to 1.5 as my second. I've made these table of values for both, and I'm going to put the lines on the graph now. I have 0, 4, 4, 0, and 2, 2. 0, 4, 4, 0, 2, 2. I have to draw a line through these. I check my symbol, and I realize it has to be a dotted line. There is no extra or equal to line underneath the symbol. Now it's time to shade. I'm going to shade this side of the line or that side of the line. To find out which, I do a test point. I'm allowed to use 0, 0 as my test point. So I plug 0, 0 into this equation, and I get 0 plus 0 less than 4. It simplifies to 0 less than 4, which is true. True means towards, so I shade from my line towards my test point. This was the test point. So shading from my line towards this test point means I'm shading down and to the left this time. I choose a direction for my shading, and I shade from the line to the edge of the graph all the way through the coordinate plane. This is what it looks like. But now I have to graph my second inequality. I have to finish my table of values. Y is equal to 1.5, so the y side of the table is 1.5 all the way down. For the x side, I pick any numbers I want. I'm going to choose 0, 2, and negative 3. Graphing these points, I have 0, 1.5, which is right here, 2, 1.5, which is right here, and negative 3, 1.5, which is right here. I have to draw a line through these points. I do see the little or equal to line underneath my symbol, so it means it is a solid line. I draw this solid line all the way through the graph through those points. It's time to do my test point. Again, I'm allowed to use 0, 0 as the test point because the line does not go through 0, 0. So I plug 0, 0 into this equation, and I get 0 less than or equal to 1.5. Again, this is true. So I shade from my line towards my test point. In this case, that means down. Choosing a direction for my shading that is different from the direction I chose for the first inequality, I draw shading all the way down from my line to the edge of the graph, all the way across. What I have done when I've done this system of two inequalities is I have divided my graph into 4 regions. One of the regions is up here. It's not shaded at all. It's not part of the answer. Another region is here. It's shaded but only by one of the lines. It's also not part of the answer for the system. Here's another bit of shading, which is shaded by the other line. It's also not part of the answer for the system. The answer is the double shaded region, which takes on this checkerboard pattern when you choose your shading direction carefully. The checkerboard area is the answer for this system of inequalities. Here's another example of a system of inequalities. We have y greater than or equal to x plus 2, which creates this table of values. I'll graph the points now. I have 0, 2, negative 2, 0, and 1, 3. I have to draw a line through these points. It will be a solid line. And I draw it all the way through the graph. It's time for my test point. If I plug 0, 0 into this inequality, I get 0 greater than or equal to 0 plus 2, which simplifies to 0 greater than or equal to 2, which is false. I'm going to be shading away from my test point. The test point 0, 0 is down here, so shading away means this is shading up. It's time to graph my second inequality. I have y is less than x minus 2. Here's my table of values. I'll graph those points now. 0, negative 2 is here. 2, 0 is here. And 1, negative 1 is there. I'm going to draw a line through those 3 points. This symbol tells me it should be a dotted line. So I am drawing my dotted line all the way through the graph, through those points. It's time for the test point. If I use 0, 0 as my test point, I get 0 is less than 0 minus 2, which simplifies to 0 is less than negative 2. That is false. So I will be shading away from my test point. Here's the test point. Shading away means shading here. And I shade all the way through the graph. This is an interesting exception to the systems of inequalities because there is no checkerboard pattern here. Because these are parallel lines, they will never cross. And because they're shaded away from each other, the shadings will never cross. But we still have our answer showing on the graph. This is how you shade a system of inequalities.